Okay, so let's have a very quick tour over some useful functions in Python. Obviously, there are a lot of functions in Python, but I will be covering just a few of them that I think with the passage of time, we will be covering more and more, but let's start. A function or sometimes particularly a built-in function is basically a feature from the language that is supplied for the users to achieve particular task. For example, a round function. If you give round, for example, round, let's say 4.6. This 4.6 is a floating point number, and rounding means make it as integer. What round does is it finds the nearest integer to 4.6. And the nearest integer in this case is 5, because 5 is more closer to 4.6 than 4. However, if you call round, for example, on 4.3, then the result will be 4, because 4 is more closer to 4.3 than 5. So that's one use of round. It rounds, basically rounds a floating point number to the nearest integer. Another use of round is if you give another argument, that is called an argument to the function. For example, when you write print, let's say a, this a is called argument to a function print. Similarly, round is a function, 4.6 is an argument. Round is a function, 4.3 is an argument. We will see functions in details, and we will be writing our own functions as well. But for now, just bear with me that functions are these kind of features that are available. However, we will be writing our own functions later on. So this particular function accepts two arguments. So round has two different kind of implementation. One is when it accepts only one input argument, it returns the nearest integer to that. If it accepts a floating point number as well as another argument, like here we have 3, that means after point, after decimal, go to 3 places only and then round up, then round. For example, this 4.55, and then 8 will be rounded based on its next value. If the next value is larger than 5, then 8 will go to 9 and stop. If the next value is smaller than 5, then 8 will stay as 8, and the result will be 3 decimal places after this. Let's practice this round function just on a Jupyter notebook very quickly. Let's see. So here we are. So let's say print round, let's say 4.556, and in this case the result will be 4.5. And the reason is 4.5, when it's rounded up, it stays to 5. And the reason is this 4.556, it is more closer to 5 than 4. However, if you just print round 4. Let's say 345, let's say, and the result will be 4. The reason is 4.345 is more closer to 4. However, if you call this round function with more than one argument, for example 4.556789, let's say, or with argument let's say 2, that means the result should be only 2 decimal places after the decimal point. So in this case, the result is 4.56, and the reason is this 5 is rounded based on the next digit, and the next digit is larger than 5, hence it is rounded up. So 4.56. If, however, I call this function for 3, then what do you think? What will be the result? It will be 4.55, and the 6 will be rounded up based on this 7, and it will become 4.557. Yes. However, if, for example, there will be a value at the place of 7, if there is a value, let's say 3, then you call this function then 4.556, and then based on the next value 3, the 6 will stay as 6 rather than going to 9, and the result will be 4.556. Yeah, so that's the round function basically. Another function is div mode. div mode function basically divides and returns quotient and remainder. So in the next video, we will be seeing this div mode in detail, how it actually works and how it is useful. So in this particular video, we saw round function. In the next video, we will see div mode, and there are a couple of more functions that we will see in the upcoming videos. So hope to see you in the next video. So in the last video, we saw round function that sometimes accepts one argument and sometimes accept two arguments and behave accordingly. In this particular video, we are going to see another function, div mode, and it accepts two arguments, two different arguments, maybe same or different arguments, and it returns two outputs, two numbers. It returns basically quotient and remainder. For example, in this particular case, the quotient is 5 and the remainder is 2, because if 27 is divided by 5, the result is 5, but then the remainder is 2. And the result is returned in a kind of an ordered pair, and these kind of collection in which we have two or more elements, we call these collection as tuple, that we will see in detail when we will see the data structures module of this course. But right now, just bear with me that it returns two numbers, two elements, and the two elements are ordered in an ordered pair, which is called a tuple. A tuple is not just an ordered pair. It can have 3, 4, 5, or 7, or maybe several elements. But right now, we will a tuple is just an ordered list, which we will see in detail. So let's see the working of this div mode function in Jupyter Notebook. Let's see. So let's say we have div mode. Let's say, for example, we have 34, and then we have, let's say, 10, or maybe let's say 9. So what do you think? What will be the quotient and what will be the remainder? So 9, 18, 27. So 3 is the quotient, and the remainder is 7. So 3 is quotient and 7 is the remainder. So and if you save the result, for example, if you save the result in a variable, let's say G. So if you see the G, the type of G, if you just type the type of, if you just print the type of G, it's a tuple, which we will see in details. And if you see the contents of G, the contents of G are 3 and 7. And if you want to access each element independently, then you can access the first element, because if there are multiple elements in a variable, normally that kind of variables are called collections, that we will see in detail later on. And these are the indexing, the positioning is start by 0 rather than 1. So G0 means the first element of G, which is 3 in this case, and the second element of G is 1 at 1, which is 7. So this is called the index or position of elements or data in this particular collection. We will see these indexing and all these kind of collections in detail in the data structures course, when we will see arrays and strings and different kind of structures. But and div mode sometimes is basically sometimes it is helpful. By the way, you can achieve div mode by another thing. For example, if you want to achieve div mode 34/9, you can do the same thing by, let's say, 34 divided by double divided by 9. That will give you a quotient, and the quotient is 3. And further, if you write 34 remainder 9, and that will give you the remainder that you need. So you can call that function div mode, or you can use these two. There are multiple ways of doing the same stuff. Okay, so yes, so I mean, sometimes it is useful when you're coding and knowing this kind of function that returns quotient and remainder. Okay, next function that is more useful is instance, and we will see this function in the next video. So hope to see you in the next video. Okay, this function is instance. It actually returns either true or false, and it just checks that particular given data value belongs to this type or not. For example, if you want to check whether 1 has type integer, so you can check that using this function. By the way, you know that 1 is of type integer, then you may think that why on earth one should be interested in checking the type of 1 if somebody know it is integer. Sometimes we have certain variables and certain data is stored in it, and we want to check the data inside it belongs to which kind of type. And in several cases, the value to this variable is not assigned by us. It may be read from some file, or maybe through input a user gives some number or something like so. So sometimes it becomes important to check the type of a particular variable. If we are expecting a particular type of the input and the input is different, then this function might be helpful somewhere. Either way, this is a function available in Python, and it checks whether the given value has a particular type or not. So is instance 1 int returns true? Is instance 1.0 integer? That returns false, maybe, because this is a floating point number. And you can check a particular value belongs to one of the several types or not. You can give several types in a tuple, and you can check whether it belongs to this or not. So let's go to Jupyter Notebook and see actually how it works. So by the way, this is the same notebook that we have that we are populating. So hold on with me. At the end of the day, we'll be having one notebook complete. So is instance, let's say 3, is that instance of integer? The result is true in this particular case. If, for example, we check whether is instance 3.4 is that an integer? The answer is no, it is not an integer. If, for example, we check if this is not integer, then maybe it is a float. The answer is yes. Or maybe we check that, for example, if that value is either float or integer. If it is one of these, then check that a particular value, in this particular case 3.4, whether it belongs to one of these types. We can increase these types, for example. So let's say we gave a complex number here and check is instance, let's say 2 plus 3j, that's a complex number, and let's say we ask whether it is an integer or float or not. The result is obviously false, and the reason is it is neither integer nor float. Or even if we give a string there, str, so it will still say no, it is not any of these. But maybe there is a complex data type. If we see that says yes, because it is complex. So sometimes this is instance becomes really useful. Next function is power. So power, you can compute power, by the way, using for example, if you want to compute x raised to the power y, you can use double star, and that computes exactly x raised to the power y. Or equivalently, you can call the function pow x comma y, and that will give you the same result as this one. But power sometimes take 3 arguments as well, and in that case it performs the power function in a different behavior. So for example, if you supply 3 arguments, what it does, it raise y to x raised to the power y, whatever the result is, then it takes the remainder by z and gives the result. So let's see the functioning of this power function in Jupyter Notebook. So let's say power, I want to compute 2 raised to the power 4. The result is 16. No problem. 2 raised to the power 4, I can compute the result 16 this way as well. But here is another way. How can we use this? 2 raised to the power 4, whatever the result is, then I want to take the remainder by, let's say, I want to take the remainder by 7. 2 raised to the power 4 is 16, then if we take the remainder by 7, the result will be 2, and that's the result 2. So that's how you can use this power function. I'm just introducing you some built-in functions that are available. There are so many functions that are available. I'm just getting you comfortable with these kind of functions so that in future, if you see another function that you have not seen here, you'll be able to use it and apply it. In this particular video, we saw this isInstance function and this power function. In the next video, we will see one more function that will allow you to take input from the user. So far, we are supplying values or assigning values to variables directly. What if on the fly we want to give the values and those values should be assigned to the variables? So in the next video, we will see the function. We will see a function that will allow you to give input from the keyboard. Hope to see you in the next video. So in this video, we are going to see a very important function called input. This function is this is beneficial for taking input from the keyboard from the user. The way to call this function is you type input and then you type a message that actually describes the expected entry. That, for example, enter something. If you want somebody to, or tell somebody to just enter, let's say, a number, you can write enter number, or any specification to help the user to enter whatever input the user want to enters properly. One thing is that no matter what the user will enter, the variable a will be having type string, str. So even if you enter a number, let's say 12 or 34 or whatever, that will be received as a string. And then there are ways to convert string to number if that really was a number. So whatever you receive using input function will be a string. And then there are ways to deal with that string if that was a number, how to convert that string to a number, and so on. So for example, let's see on the Jupyter Notebook how it works. So let's see, for example, x is equal to input, enter a number, let's say, and then if I press shift enter, a prompt will appear in front of you that will require you to enter a number. For example, if I enter, let's say 56, and then I press enter, not shift enter, enter, then x will receive 56. Now you might be thinking this 56 is an integer, so the type of x should be an integer, but this is not the case. The type of x will be a string. And the reason is whatever you enter is received as characters 5 and 6. Even if you have entered something else, that would have been received as a sequence of characters. So this is no longer a 5 as a digit 5, 6 as a digit 6. These are some characters, sequence of characters. Now, if you want to, there are ways to convert this x. For example, maybe you want, let's say, y or x as int x. So this means you have now converted this string to integer, and then whatever the result is, you have stored that result in x again. If you now see the type of x, the result is integer, and you can, for example, print x minus 34, and the result is 22 because x was 56. So this input function is, it is, and one way, by the way, if you're expecting an integer or a float value, for example, let's say you are expecting a float value, then it is good to write input, let's say, enter a real number, maybe, or any message, and then at this particular time, at the time of input, then it is okay to convert that thing to a float, and it will become a float. Yeah, that's it. So now, for example, you enter 12.5. If you see the type of a now, type of a will be float. Okay, but there are problems. For example, if you're expecting float and somebody enters something that is not float, for example, a or let's say b equals float input enter a real number, let's say, and then you press shift enter and somebody just enters, let's say, ABC. So now this is not a float. ABC cannot be converted to a real number no matter what. So you will catch an error. There are ways to avoid these kind of errors and program breaks using exception handling, and there are other ways, but be careful. I mean, the user is not, the one who is going to enter the input, if that user is not restricted enough, then you can get errors. This is not the case that whatever you will enter, it will be converted to a float. If whatever you have entered is really convertible to a float, then it can be convertible to a float, not otherwise. And at the input time, there is no restriction. You cannot restrict the keyboard to enter what or what not, although there are ways to do that. So that's about the input function. So we have seen some of the functions. Let me just go through quickly. We have seen input, we have seen is instance, we have seen div mode, we have seen power function, we have seen the round function, and there are several others. Yes, so from now on we will be actually moving towards basically decision making based. Sometimes we will use these kind of functions. Mostly we will be using input function, but sometimes we'll be using maybe other functions like these functions, and sometimes we will be doing decision making based on these and stuff like so. One thing that I want to tell you is, if for example you know the function name, some function, let's say like power, you know that POW, power, is a function, but you do not know how to use that function. One way is to just type a question mark in front of it and then just press shift enter, and in front of you the documentation of the power will open up. So it will tell that this is power, that's how it should be called, and then some description will be in front of you, that equivalent to x raised to the power y with no arguments, with 2 arguments, or equivalent to x raised to the power y remainder with z with 3 arguments, and so on. If you want to see implementation of this function as well, we will see the functions later on, but if you want to see more about the help, you can type the double double question mark, and more things should be open up in front of you. So yeah, in this particular case, this power function does not have an implementation in Python, so the single question mark and double question mark are the same. One more way is to use the help function, help pow, and you will get a lot of information about the power, how for example help on built-in function pow in module built-in, so this is pow, this is equivalent to this, some key types and stuff like so. Or for example, you want to know how can I use the input function, for example, so you can write help on input, and this is how this can be used. So sometimes it is okay if you know the name of some function and you know how to use it, you can just open up the documentation right here in Jupyter Notebook by either using a help function, or you can use just a question mark in front of the name and so on. So that's about the functions. In the next video, we will be seeing the power of comparisons and the decision making, or sometimes called the control flow. So the real fun will begin from the next video, because we will be actually deciding which part of the code should run and which part should not run based on certain conditions. So hope to see you in the next video.